Alright, in this video we're going to be talking about using functions that accept arguments to make repeatable shapes that we can change the position and size of while preserving whatever the shape is that we want to draw. So for this example, I've come up with this little pattern that's a circle, tangent to a square, and a rectangle that's twice as wide as it is tall. And you can see that this pattern, based on the three function calls in lines 7, 8, and 9, has been drawn 3 times, in that each one is a different size and position on the screen, but they all preserve this relationship between the circle and the two rectangular objects. In each case, they're still tangent to each other. Their relative sizes are all the same. It's almost like we're scaling this image while preserving aspect ratio. And I've also added a little bit of code in lines 25 through 27 to where if I click, we'll get this pattern drawn at different sizes depending on our mouse's Y value. And in all cases, you can see wherever I click, it draws that pattern with all of those same properties preserved. And so the way we can accomplish this without cut and pasting the code right here that's drawing the circle and the square and the rectangle is by writing a function that will draw that pattern that accepts a couple of arguments for things like the position and the size, which we're going to base the size of this whole pattern on a single size parameter, and that will end up being the diameter of our circle. And we'll just use that to be the side length of the square or the short side length of the rectangle. So based on one size parameter, we can know everything about how we need to draw this shape. So we're going to go ahead and start from scratch in a fresh P5 editor. And a couple things I like to do, we'll do in setup, we'll draw the background as white. Oops. And we can take that out of draw. And so we can make our canvas a little bigger too. We're going to make a new function. We'll just call it draw pattern since I don't really have a name for this shape that we've drawn here. We'll call it draw pattern. And before we start worrying about what arguments it accepts and that we'll fill in here, we're just going to go through and write the pattern or the function as if it already accepts those. So we know that at some point we're going to draw a circle, right? At some point we're going to draw that square, and at some point we're going to draw that rectangle. Okay, so before we draw the circle, we're going to want to set our fill and stroke. So let's go with no stroke and a fill of whatever color we want the circle to be. So we could call that circle color. Now right now that variable doesn't exist, right? But we're going to bring it into being in a minute. For the square and the rectangle, we might want to go ahead and set the fill to a different color. Maybe we'll call it square color. And maybe we do want a stroke. We'll pick a nice dark gray. So I like this gray right here, looks nice. So you'll notice in this case we've hard-coded the stroke value for the rectangle while we've let the fill value be up to some parameter. So what that means is no matter what we specify when we call draw pattern, our square and rectangle are going to have a dark gray stroke. And we'll make that stroke just a little bit thicker. Okay, so we've got to think about then the missing arguments to the circle, square, and rectangle function. Our circle needs an x, a y, and a diameter. And so we may as well just put in x, y, we'll call that diameter size, right there. But at this moment, x, y, and size are all undefined. We've never mentioned x, y, or size as variables, so we'll need to take those in as arguments to our function. So we'll say x, y, and size will be the first things that this function accepts, because we're going to use those to specify our circle, and we'll use a version of them to specify our square and our rectangle. We've also referenced 2 other undefined variables, circle color and square color. So let's add those as arguments for our function as well. Circle color and square color. So we've got this pattern function that at this moment accepts 5 arguments, x, y, size, and then 2 colors. So now all of the variables we've referenced are referencing parameters or arguments of this function. So they should be visible and defined. So our circle actually should be able to be drawn as this stands, but we still need to think about our square and a rectangle. Before we get too far, let's actually go ahead and call this draw pattern. we'll just do it wherever our mouse is for X and Y, and we'll give it a size of, let's say, 80. We'll pick two colors. So for the circle, I kind of like this nice peachy orange. And for the rectangle, we'll pick a somewhat complementary color, maybe this nice teal seafoam. Okay. So I don't want to see a big trail of these, so I'm going to also draw the background between frames for now in white. So if I run this, of course, square and rectangle, we haven't given them the arguments they need, so I don't expect much out of those. But we should see at least a circle that follows our mouse and has the specified size and specified color. Cool, that's not too bad. What we'll want to do next is think about how do we get this square to show up. So we want the square to show up directly below the circle. Remember, the circle is specified in terms of its center point, but our square is going to be specified in terms of its top left corner. So we need to come up with some x value, some y value, and we'll keep the size exactly the same as the circle's diameter. That way the square will have a side length that matches the circle's diameter. But in terms of the x, we still want it to be based on the x that we passed in for the circle center, but it needs to move to the left a little bit, because if we leave it right, at xy, we'll get a square that has a top left corner equal to the circle center. That's not what we want. It needs to move down and to the left. And specifically, it needs to move down and to the left by half the circle's diameter. So to move left, we would say x minus half of size. And to move down, we'd say y plus half of, half of size. So now our square is located where we'd like it to be. And notice we didn't hard code any values. We didn't say minus 40 pixels or plus 40 pixels because I want to be able to draw a different version of this pattern at different sizes. And now, let's get rid of this one. When my size is set to 20, I shouldn't be moving 40 pixels to the left or right. I should only be moving 10. And that's why we base everything as a percentage or proportion of that size value. Okay. So we can go ahead and put in a couple of, instead of mouse and X and Y, let's put in, we'll draw one of these at the coordinates 50, 100. We'll draw one at the coordinates 50, 200, or sorry, we'll do 50, 50. And we'll make this one a little bigger than this one. So we should have one at 50-50 with size 40 and one at 50-200 with size 100. And you'll see, okay, we've got two copies of our shape. I'm going to move the lower one down a little bit, to the right a little bit so it stays on screen. So at this point, things are looking good, right? We're able to specify x, y, and size, and you can see our colors are preserved and our relationship between the circle and the square is preserved. In both cases, regardless of where on the screen they are or their size, the square still has a side length equal to the circle's diameter. And that's because we used our x, y, and size values rather than hard-coded values. Right? If I had instead said x minus 40 pixels and y plus 40 pixels, notice that breaks the relationships here. Right? That would only look good for a really specific setting where our size was set to 80. So it would look fine in this one case, but in most cases, it's going to look wrong, right? So it's really important that I go through and I set things proportionally to my variables, to my size. So we'll put that back in. Okay, so the rectangle comes next. Now remember, x and y are talking about the center of the circle. So my rectangle needs to move over and up, right? That's where we want the top left corner of the rectangle. So to move to the right, we're going to say x plus, and in this case it'd be half of that size. That'll take us to the right by half the diameter of the circle. And to move up, we'll say y minus that same amount, 0.5 times size. Next things we specify for a rectangle are its width and its height. Remember, we wanted it to be twice as wide as it was tall, and it's as tall as the circle's diameter. So for width, we're going to say 2 times size. And for the height, we'll just say size. Okay. So again, we're specifying everything in terms of x, y, and size, or some proportion of size, right? So that our things scale as that size value changes. So when I hit play, you can see we've now created the pattern, and we can make a couple of these in different color schemes, right? They don't have to have the same. We could do one where, we have a dark orange and maybe a paler red circle, right? And just like before, when we specify whatever we put here for our circle color, the circle is that color, the rectangle is the other color. Okay, so we can go ahead and put a couple more of these on the screen and just keep testing our work by adding another function call. That's what we'll do on line 10. We'll move this one over to 150 in the x direction and up to maybe 40, and we'll draw a nice tiny one, right? We'll give it a size of just 20. And let's move it over even further so it's not overlapping. You can see that our shape is preserved relative to, regardless of position or size, we still get this same image, right? And we could go through and change our colors one more time so it's really clear what's being drawn where. Let's just draw a nice blue circle. Okay, so the biggest things to watch out for when you're working on having a pattern drawn this way using arguments are that you don't really want to have any hard-coded values inside the body of that function. So nowhere do I want to say something like x plus 40, right? 40 pixels is just an arbitrary amount. And as soon as you start doing that, you're going to start breaking the relationships between the shapes that make up your pattern. And so instead of saying plus 40, I want to say plus some proportion of size, right? Some number times size. Could be 2 times size or 0.1 times size, right? That all depends on how big or small you want this thing to be, but our size is sort of some value we choose to base our relative proportions around. And so that's what we're going to be doing here. So if you go through and you find that you have hard-coded values, right, you're going to want to rework your code until everything is defined in terms of some proportion of size or in terms of x and y. And the way you can check your work is call your function several times and give it different values, right? Give it different x and y values and make sure that things stay glued to each other in the same way that you want as they move across the screen. Okay, let's move this even further across the screen. And also give things different size values and make sure that your image looks exactly the same, just scaled according to the size, but it doesn't get stretched out or elongated. Your shapes don't start either overlapping or having space between them where you don't want to. If you do find that you have those issues, go back through, look for where you have hard-coded values, and you're going to want to replace them with proportional values based on size, right? The colors you pass in, those are pretty easy to use. You'll just set your fill based on them or your stroke. One thing that commonly pops up is that people will start wanting to add a fourth argument to something like circle. They would say circle color here, right? Remember that circle, as defined in the reference, it only accepts 3 arguments, x, y, and a diameter. If you put a color here, it doesn't mean anything. P5 will just ignore that. It's not going to change your fill. So you've got to still remember to use your fill and stroke and no stroke functions as you've always used them. And still abide by the reference when it comes to squares and rectangles, right? They take an x, a y, and a side length, or an x, a y, and a width and a height. But with those tips, you should be able to go through, pick a simple pattern, and then take in at least these 4 arguments, an x, a y, a size, and some color, and then write a function that draws that shape, right? Does each piece of it piecewise based on those arguments, and then call that function, just like we did here, repeatedly with different values. Every time you call it, you should see the entire shape drawn according to the values you provided. Thanks, and I hope this helps.